Okay, let's pick back up with another Rex. This is Rex number 7. It is log base 4 of x greater than or equal to 3. All right, we have a single term over here. We have a log term here. It is in log form. We need to put it in exponent form so we can solve for x. Get rid of the word log. That dislodges your base, and he gets to come over here and push the exponent up. So x is greater than or equal to 4 to the third power. Okay, so 4 to the third power is 64. So x is greater than or equal to 64. All right, interval notation. You are including 64, so it's a bracket, 64, and all values greater than that. So this would be the interval answer to Rex number 7. Okay, let's go to Rex number 8. Okay, something a little different about this one. I want you to get a heads up. Okay, solve log base 2 broc of x less than 4. All right, you gotta watch this. Okay, this less than sign is going to give you a heads up when we're talking about logs. Okay, because you're going to give me an interval value. You're going to have a high end value over here, but you've got to make sure that your low end value does not go below 0 in this case, or whatever would make this 0. Okay, so same thing. We're going to move this, and we're going to bump him here and move him up. So we have x less than 2 to the 4th power, x less than 16. Okay, that's fine. It can be less than 16, but remember the lowest a broc can be is anything close to 0 but not including. It's got to be greater than 0. So in interval notation, you would say, okay, the lowest that I can have is 0, not including, and then all the way up to 16, not including, because there's no equal bar. So your solution to this one is my broc can be 16, and anything less than that, x can be anything less than 16, but it cannot touch 0. So this would be your answer to number 8. So I want you to have a heads up on those less thans, okay? If you end up with x less than something, then you're going to have to account for the lowest value possible. In this case, x was our only broc. We didn't have anything else going on with x. All right, so make sure you mark that down. All right, next example. There's lots of Rex's here because I want to give you plenty to go on. This is Rex number 9. Remote example number 9. Okay, all right, solve log base 4 broc of x plus 3 greater than log base 4 2x plus 1 is that broc. Okay, now first, because we have brocs that have variables in them, we have to pull aside the broc and we have to define the illegal values. Okay, because we need those illegal values to build them into our final interval answer. So all you have to do is you have to take both brocs, and we'll take this one over here, 2x plus 1. All right, and you're going to set it greater than 0 because your broc has to be greater than 0. So we're going to set it greater than 0 to tell us which values we need to pretty much stay away from. All right, -3. So one thing we know is x, whatever we solve for, x has to be greater than -3. If any of our values are less than -3, they are extraneous and they are out. Okay, -1, -1, 2x greater than -1, divide by 2, divide by 2, x greater than -1/2. Okay, now, if it's greater than -1/2, then you know it's greater than -3. So this is going to be our lowest possible value, okay? So if it's greater than -3, that means greater than -1/2 covers this, okay? If you're not sure, you can always do a little number line. This helps a lot of kids. They're not sure when they have one that looks like this. Let's say we graph that. That'd be -3, and you'd say, okay, not including, and then we go this way, anything greater than -3. And then let's say you wanted to graph your other one, -1/2, so we'd say, okay, open circle, or in this case, parentheses, because it's interval, -1/2, and you would shade everything in red. So where the two colors come together, that's going to be the overall interval. Okay, so our lowest possible value is -1/2, not including. Right, now we have to solve it. Are our bases the same on both sides? If you answered yes, you answered correctly. These are identical. So we can just take the blocks and set them equal to one another. So now we can solve for x. X plus 3 is greater than 2x plus 1. Subtract x, subtract x, subtract 1, subtract 1. Okay, that's going to give me 2 over here, right, is greater than x, or, let's turn it around, x is less than 2. All right, so we've got a less than. So that means that it can be less than 2, but it has to be greater than negative 1/2. So that's going to be the low end of our interval. So we're going to say, okay, negative 1/2, not including, is the absolute lowest, all the way up to 2 is the absolute highest because x's are less than 2. So this would be the solution. So you have to make sure when you've got variables in your blocks and you've got an inequality, I want you to pull out the possible lowest values. You can find the intersection here and figure out, okay, anything greater than negative 1/2 is legit, but x also has to be less than 2. So that's why this would be the answer. Okay, you guys know interval notation. All right, very good. Let's do another one. All right, let's look at Rex number 10, and I think this will probably Rex number 10. Okay, solve. Log base 5 Brock 2x plus 1 less than or equal to log base 5 x plus 4. Okay, first we have to identify our limits, right, on our values. So 2x plus 1 has to be greater than 0. Subtract 1, subtract 1. 2x greater than negative 1. Divide by 2, divide by 2. X has to be greater than negative 1/2. Over here, x plus 4 greater than 0. Subtract 4, subtract 4. X must be greater than negative 4. Okay, well, just like in the last problem, if it's greater than negative 1/2, then it's certainly going to be greater than negative 4. So this will be our low value. And remember, this, okay, when we did this, you're always going to have your plain, pure inequality here. All right, so that takes care of this. All right, now let's solve. So we'll have, whoops, trying to get the word solve in there. Okay, so we have 2x plus 1, which is my left Brock, okay, less than or equal to my right Brock, which is x plus 4. Okay, so I'm going to subtract x, subtract x, subtract 1, subtract 1. So we have x has to be less than or equal to, all right, and that's 4 minus 1, which is 3. Okay, so it's less than or equal to 3, so that means it's going to include 3, but it has to be greater than negative 1/2, but not including. So negative 1/2, the lowest value, not including, that's why there's a parentheses, all the way up to a high value of 3, and we can include 3 because we have the equal bar, okay? So we have a parentheses on the left, negative 1/2, 3 is our highest possible, that came from the solving portion, and we know that 3 is included, so you're going to have a bracket. So this is going to be your answer here, okay? This is what I'd be looking for right here. Okay, well, I think we've covered, you can also do quadratics in solving these like I showed you earlier, but you have to test all your solutions. Okay, and in your inequalities, you have to make sure if it's a less than situation, x is less than, make sure you bottom out at whatever value, right, keeps it greater than 0. Okay, hope that helped. Your assignments are posted, and I think you'll enjoy these. They're kind of easy. Just check those solutions, guys, okay? All right, take care.